Hello again, it's Miss D, and we're talking about oxyfuel flames. So let's light some stuff on fire. All right, here we go. So a cutting torch can be used manually or as part of a machine to cut out steel parts. So in about 1880, oxyfuel was used to cut through thin metal. So around 1900s, oxygen was actually added and introduced as a stream to cut metal. This resulted in cutting tips on torches with preheating holes that surround a central oxygen hole in the center, and it makes oxyfuel cutting more practical. Okay, so this later development actually we use today, so which is really great. Okay, so there are three different types of flames that are used. A neutral flame, this means that this is 50% fuel gas and 50% oxygen. A carburizing flame, or a flame with an excess of fuel gas. Or an oxidizing flame, which has an excess of oxygen. We'll get further into flames, but I want you to be familiar with the terminology and kind of what it kind of sort of looks like. Okay, so fuel gases. Fuel gases are made up of hydrogen and carbon atoms. When the atoms come together, they form molecules. So each molecule has a specific type, number, and arrangement of atoms. Pretty cool, right? Science. So the number of atoms in each molecule of gas varies. Okay, so a molecule of acetylene is made up of 2 hydrogen and 2 carbon atoms. So C2, it tells me 2 carbons and 2 hydrogens. Pretty cool, right? So a molecule of propane is 8 hydrogen and 3 carbons. So here's our 3 carbons and our 8 hydrogens. Starting to make sense now, right? So acetylene, 2 carbons and 2 hydrogen. So we can see the difference of how they're chained together, okay? Well, when a mixture of oxygen molecules are broken down and the bond is formed with other molecules. So when the acetylene molecules are broken down, these release energy in the form of heat and light. The rate this reaction occurs results in a change of temperature. It also makes a really, really bright light. So this will continue as long as there's oxygen. This chemical reaction is known as combustion. Okay, and this is rapid oxidation. Who knew science was so cool? All right, so the number of oxygen atoms required to combust the fuel gas varies depending on the makeup of the fuel gas. So we can see the chart that acetylene and natural gas use the least amount of oxygen for combustion. So it says for acetylene, we need 2.5 oxygens. For natural gas, we need 2. It's actually pretty cool, right? All right, so there are 2 different chemical reactions that happens when acetylene combusts. The first reaction is called the primary combustion, and this creates the inner cone of the flame. So this would be the inner cone right here, this part of the flame, okay? This is where the acetylene and oxygen this is where the acetylene, oxygen, and carbon atoms come together, okay? The reaction, it forms carbon monoxide, meaning 1, and hydrogen, so C1H1. Okay, the second reaction is the outer envelope. Okay, so this is primary, secondary. Pretty cool. All right, so in the secondary reaction, the oxygen from the air unites with free hydrogen and forms a water vapor, and it makes more heat. So the reaction also has the carbon monoxide united with other oxygens, and they make carbon dioxide. So ultimately, the final products of the hydrocarbon flames are the same, water vapor and carbon dioxide. So remember that the temperature, the rate of combustion, and heat released makes each type of flame different. So these characteristics are what makes some gases a little bit better than others, depending on what we're trying to accomplish. Okay, so as we can see, the combustion rate is how fast or at the speed in which a flame burns. The burn rate of a fuel gas is given in feet per second. So it says 22.7 foot per second for acetylene, 15.4 for MAP, 15.2 for gas, propane 12.2, propylene 15.1, hydrogen. Wow, that's a whole bunch. Maybe let's not play with hydrogen. So acetylene is one of the hottest gases that we can use. Okay, so the first picture shows what acetylene looks like when it is first lit, okay? So it's really has really liquidy flames, okay? The second flame is called a carburizing flame or an excess of acetylene. The third is a neutral flame. This is the type that we want to use for cutting and welding. We have the same amount of oxygen and acetylene or fuel gas, okay? So the fourth, this flame shows what the flame should look like when using the oxygen cutting handle and what the flame tip should look like near the torch head. So if we look really carefully, we can actually see right here. Bing, bing. Let's see if I can make it bigger. All right, so we can see right here, this is what a neutral flame would look like. But what happens is when we add that oxygen flame, it actually makes these little points on the flame, okay? And that's what we want. Let's see, go back. All right. Okay, so the last flame is an oxidizing flame. This is an excess of oxygen, and it's not really meant for cutting, and it's really meant for particular types of welding. Okay, so the heat of a neutral flame is around 5,589 degrees Fahrenheit. The oxidizing flame, 5,615, and the flame burns in two parts, the inner cone and the outer envelope. Although there's more heat produced by the outer envelope, the primary flame or the inner cone is what we use, okay? So remember, any oxygen-rich fuel gas mixture may have a combustion rate greater than the rate of the tip, which means this can lead to backfire or flashback. So should any type of issue happen, close the oxygen valve immediately and then close the fuel gas. This will stop things from happening. Okay, so let's learn a little bit more about gases. Okay, acetylene is the most commonly used fuel gas. When mixed with oxygen, acetylene produces a high heat and high temperature flame. Acetylene is colorless, lighter than air, and has a funny garlic or like eggy smell. You will, if you smell it, you'll be like, ew, gross. So because of the instability of acetylene, it should never be used at pressures above 15 psi. We don't want to subject it to electrical shock, excessive heat, or even rough handling. And copper pipe should never, ever be used because it can form what's called copper acetylide, which is explosive. So we don't want to do that either. All right, so acetylene is made by mixing calcium carbide and water. Calcium carbide is made by smelting coke, which is a coal byproduct, and lime in an airtight furnace. So after they smelt the calcium carbide and it's cooled and crushed and packed into airtight containers. Then an acetylene generator is used to mix the calcium carbide with water. So if we see here, so once the calcium carbide is dropped into this large tank of water in the generator, when the carbon in the calcium carbide mix with the hydrogen, it forms two products. The first product is acetylene, which bubbles out and they catch it. So here's our water, here's our calcium carbide, and what they're doing, they catch the acetylene gas, okay? And the calcium hydroxide, it drops to the bottom. So then we can scoop it out and start it all over again. Okay, so acetone is a liquid solvent. So what happens is a porous material like a brick or something like that and acetone are used inside the acetylene cylinders to make the gas more stable. So the rate that we withdraw gas should be not more than 15 psi, otherwise acetylene becomes unstable and it can explode. We don't want that. Heat and temperature. When we work with acetylene flame, it needs to be moved consistently to obtain a uniform heating of the parts. The highest temperature of the oxyacetylene flame is near and around the inner cone. So for welding, the high temperature of the acetylene flame has advantages over other types of gases. When welding with oxyacetylene, the inner cone is used to heat the weld pool.
Stay tuned for more oxyacetylene videos.
Weld the world.